In this video, we're going to talk about 4.3 Objective 1, where we use measures of variation to compare data sets. So first question, consider two grocery stores at which the mean time in line is the same, but the variation is different. In which store would you expect the customers to have more complaints about the waiting time and explain? We would expect more complaints with the store with more variation. The customers would have more complaints about the waiting time at the store that has more variation because some customers would have longer waits and might think they are being treated unequally. So now let's go ahead and look at problem 2 here. This is going to look a whole lot like another problem that we did recently. Listed are amounts in millions of dollars collected from parking meters by Brinks and others in New York City during a similar time period at the time when parking meters were fed by cash. A larger data set was used to convict 5 Brinks employees of grand larceny. Find the range and standard deviation for each data set. And do you notice any significant difference in variation between the two data sets? So let's go ahead and put in our data here. And we're going to have 1.29, 1.52, 1.34, 1.53, 1.38, 1.65, 1.75, 1.71, 1.65, 1.57. I'll just put my other data over here, 2.15, 1.93, 1.49, 1.57, 1.52, 1.66, 1.86, 1.58, 1.59, 1.75, and we've got stat calc one variable statistics on L1, and then we want the range. So we're going to find max minus min. So 1.75 minus 1.55 is 0.2 million. And then let's see, the standard deviation here to the nearest thousandth is 0.159. And let's look at our data for L2. When the collector was someone other than Brinks, and our standard deviation is 0.212, and max minus min 2.15 minus 1.49 is 0.66, and it's a greater range for when the collectors was not Brinks. The difference is not substantial. And the standard deviations, there's a greater standard deviation when the collector was not Brinks, but the difference is not substantial. Okay, so let's go ahead and look here. Listed below are contributions in dollars made to 2 presidential candidates in a recent election. All contributions are from the same zip code. So let's go ahead and put our data in here. Let's clear our lists first. There we go. Stat, edit. And we have 275, 473, 300, 1750, another 1750, 700, 200, 1066, 1600, 245, 850, 1750, 375, 270, and 250. And then Over here we have 60, 95, 260, 303, 250, 700, 330, 400, 1350, 1400, 400, another 400, 35, 222, and 200. Let's analyze this data. Stat, calc, one variable statistics, second L1. And the range is going to be max minus min. So that's 1750 minus 200 is going to be 1550. And the standard deviation is going to be 626 when we round to the nearest dollar. And then let's look at stat, calc, one variable statistics for L2. Then the range is going to be 1400 minus 35. It's going to be 1365. And our standard deviation, I have to write that down, was 418. So there's greater variation for candidate A, right? But the difference is not substantial in the ranges there. And then for the standard deviation is greater for candidate A, but also not substantial here. All right. Waiting times in minutes are given in the chart below for a bank with a single file line and banks with individual lines. Would you expect customers to be more frustrated with the waits at one bank than the other? So let's go ahead and take a look. Probably the one with more variation. So where we might expect there to be more complaints, just like we talked about with the grocery store. So 6.5, 6.5, 6.7, 6.8, 7.2, 7.4, another 7.4, 7.6, 7.6, and 7.7, and 4.3, 5.4, 5.9, 6.1, 6.7, 7.8, 7.7, 8.5, 9.4, and 9.7. And let's analyze these. Stat, calc, one variable statistics. Let's work on L1 first. And let's write the standard deviation down first. To the nearest hundredth is 0.47. And then the range we'll figure out is max minus min. I get that to be 1.2 minutes. Variable statistics on L2 now. And our standard deviation is 1.77. And our max minus our min, 7.9 minus 4.3 is 5.4. And the customers would probably be more frustrated with the bank with individual lines because the variation is more than twice the variation of the bank with a single file line. There's just more consistent service, even though there's a chance that you could go faster with individual lines. Sometimes you could go way longer, but you're going to get a pretty consistent service at the bank with a single file line. The report claims that the returns for the investment portfolios with a single stock have a standard deviation of 0.55, while the returns for portfolios with 32 stocks have a standard deviation of 0.319. Explain how the standard deviation measures the risk in these two types of portfolios. So the standard deviation, a lower standard deviation means less certainty in the return and more risk. Hence, the returns for portfolios with 32 stocks will have more risk than the ones with a single stock. So and number 6, for the past 100 years, the mean batting average in the major leagues has remained fairly consistent at 0.241. However, the standard deviation of batting averages has decreased from about 0.041 in the 1910s to 0.027 at present. What does this tell us about the batting averages of players? And based on these facts, would you expect the batting averages above 350, that's 0.350, to be more or less common today than in the past? And explain. The batting averages are less varied today because the standard deviation decreased. They're closer grouping, right? And because the mean is unchanged, the batting averages above 350 are less common today because the standard deviation is lower. Thus, it is less probable to have such a high batting average today. So I think that is it. Yes, it is. We'll come back next time and we will talk about 4.3 Objective 2. See you for the next video.